Kurt Pesch with General Dynamics Land Systems, and this is the Stryker Mobile Expeditionary High Energy Laser System. So there's a number of systems that are shown on this vehicle. There is a target acquisition system. There's an electronic warfare system used to scramble signals to UAVs. And essentially the laser is the key piece of equipment that we demonstrated on the vehicle last year, and we're integrating a growth to that system from a 2 kilowatt to a 5 kilowatt system. So inherently, the Stryker is capable of producing about 15 kilowatts worth of power. And for the missions that we're looking to go demonstrate off at Army installations, we're able to have a period of laze time, or for the other systems, the ability to operate those systems over a set amount of time, drop down to a recharge cycle, and then do it all over again.
We built the compact laser weapon system. It's the component you see there at the top with the beam controller. We have a beam director on top of the vehicle, and we control the laser from that location. And you can, it's primarily for counter UAS, counter unmanned aerial systems, and to destroy those before they get close to any kind of platforms.
Land Systems, and I'm here today with my partner Dave DeYoung from the Boeing Corporation to give a brief overview of a project we've been working on collectively and with some other organizations that I'll mention in a moment, to bring directed energy, specifically lasers, to the battlefield in a very short time frame to the U.S. Army, and particularly to the maneuver formations. And I'll talk about that in more detail on subsequent slides. Our role is not on the laser side of the equation. We're a combat vehicle manufacturer, a systems integrator, vehicle designer. So our expertise is making things go together on a platform that is in the U.S. Army's combat brigades. And we rely on the companies like Boeing, who have the expertise in laser weapons and other aspects of the system. And I'll show you that more on subsequent slides. This is a couple of pictures here of what we're doing. We're collaborating with a number of Army commands from Fort Sill, the Fire Center, Space Missile Defense Command here in Huntsville, Amerdeck also here in Huntsville, and as well as the Maneuver Center down at Fort Benning on the Army side. And as I mentioned, we're collaborating with a number of industry partners as well, primarily Boeing Corporation on phase 1 of our project. And the goal is to bring this counter UAS, counter UAV capability to the Army's maneuver formations. If any of you attended the briefings earlier today about the IFPC system, its initial place on the battlefield is going to be to protect fixed and semi-fixed high-value assets. And right now, the Army's maneuver formations lack short-range air defense capability because of the redesign that the Army went through in the early 2000s. So we're trying to work to figure out a way to bring that capability back to the maneuver formations inside the United States Army. We started this a few years ago on IRAD funds, and we're continuing that today. And we're in the phase 1 of a 2-year, or what we're calling a multi-year project, 2-phase project. And we are leveraging the work that's being done by Space Missile Defense Command on their high energy laser project, which is advancing the state of the art of the technology for everything from lasers to fire control. And so we're going to benefit from their work in that program. Phase 1 of the project is to put together a system on a Stryker vehicle, which is the mainstay of the Army Stryker Brigade combat teams, and is present in the other 2 brigade combat teams as well, using Boeing's compact laser weapon system, which is a 2 kilowatt system that they developed for another Department of Defense user, and put that on a vehicle for the maneuver fire integration exercise next month out at Fort Sill, so that the Army can experiment with the tactics, techniques, procedures, command and control, and battlefield effects of a system like this in preparation for going to a higher power, more capable system. But even at this power level, what we have found is that it does have real, if somewhat limited, capabilities on the battlefield. And I'll talk about that in just a second. We hope the system is successful next month, and I'll mention what we have been able to accomplish so far. And then we are hopeful that the Fire Center will nominate it for participation in a future Army warfighting assessment, either I doubt this year there's time for it, but maybe in 2017. While we initially started with phase 2 being a high power system, which is defined in the 30 kilowatt or greater power level, based on the research done here at SMDC, we think that is still possible, and we're going to pursue that path, and I'll talk about that in a moment. But just in the last couple of months, we've been hearing from our Army customers or clients that we're working with that they might be interested in a more intermediate level power level, something between what we're demonstrating in phase 1 and something, but not at the power that is capable in phase 2 to provide the real operational effects that the Army is looking for. And I'll describe that in a moment as well. The scope of the project you can see here, we did the systems integration on the combat vehicle. PM Stryker provided us a Stryker vehicle on loan at no cost, which is very appreciative of that from them. As I mentioned, Boeing provided us with their laser system that was designed to be a man-portable system for another Department of Defense user. And we worked with the Fort Sill folks at the Fire Center to make sure that everything could integrate into the network architecture they have on their test range and talk to the radars, talk to the fire control systems, talk to the range control systems out there so it could be operated safely. Until last Thursday, Fort Sill had never fired a high-power laser on their range, so that was one of their major goals, was to make sure they could accomplish it safely. And we were out there last Thursday, and it worked, and they didn't have any problems. So that was a major exercise goal for them that we had to help them accomplish. We received, somebody asked me this earlier, we received the information on the vehicle from a number of other systems that are being tested at the Maneuver Fires exercise as well. There's some modified Army radars, if you're familiar with Sentinel or Q-50, that have been modified to pick up these low, slow, small flying UAV targets that are so hard to find on the battlefield that we're finding countries around the world are using with great effect. And we're also linked into the Army's new battle command system for air and missile defense that has the unfortunate acronym of MAFIA, stands for Maneuver Aviation Fires Integrated Architecture, or MAFIA for short. And you can kind of see there in the bottom right what our demonstrator vehicle looks like out there on the range at Fort Sill. And here's a few pictures taken in the last couple of weeks out there on the range. The acronym that the Army gave the vehicle is the Stryker MEHL, which stands for Mobile Expeditionary High Energy Laser. It's a proof of principle platform. It does not yet have a high energy laser on it, as I've already mentioned, but that's what we're working with. And you'll see there on the lower left is a picture from the lower right, just last week, as it was coming back from a successful engagement downrange. They flew 5 small UAV targets for us to shoot at during the rehearsal for the exercise next month. We were able to engage 4 out of the 5. There's 1 target we didn't pick up out there on the in the scatter on the range. Of the 4 that we did engage, 3 were kills. We destroyed the UAV sufficiently that or enough on the UAV that it crashed, and 1 was a system defeat in that we destroyed the control mechanism and it had a fail-safe return to home program in it, and so it flew back to its ground station. So it wasn't a hard kill. They called it a soft kill. And you can see a picture there on the top. That's the small Phantom. It's a commercial quadcopter UAV that was being used as a target. This just gives a kind of a fuzzy overview of what the system looks like. I just want to mention that what we did was an installation. We took the system as designed by Boeing for their other customer, and we took the vehicle as provided to us by PM Stryker and didn't modify either one. We hooked them together, we installed things to make the power and the communications and the operator stations work. If we were to actually go to a full-scale integration, it would look a lot different than this, because we could use some of the vehicle's onboard systems to do the things that some of those boxes you see in blue provide for the system in its man-portable mode. Now, what do we think is going to happen next? Well, first off, in in April, we hope that at MIFIX we're successful in the actual demonstration test that takes place the 2nd and 3rd weeks of April. But following that, we see 2 potential paths. One is to continue to work with our customers on staying abreast with the state of the art of laser technology and beam control technology, and track that as it goes to the kind of power levels that the Army would ultimately like to see in a platform that can do counter UAV work as well as counter RAM or rocket artillery and mortar work. In parallel with that, but in a shorter time span, is this potential for a multi-mission platform. And what we are hearing, and I don't want to speak for any of the Army commands that we talk to, is that they're interested in bringing this capability to the formation without having to add another vehicle or soldiers to it, because the Army doesn't have the force structure anymore for short-range air defense. So we're looking at how to put this laser capability, perhaps some electronic warfare capability, maybe even the acquisition radar capability onto a recon vehicle operated by scouts. So they would be on the part of the battlefield that could provide this coverage to their parent unit, or maybe to put it on the field artillery observer's vehicle and give them an added capability or a second mission to make them a fires integrated platform combining air defense and artillery. So we're anxiously waiting for April to come around so we can do the test, get the kind of feedback that the Army will get by having its folks out on the range, and then see what comes next. And that, in the interest of time, is a brief overview, and then I'm open to questions, and I hope if you have anything of a technical nature on the laser side of the question, that's why Dave's up here to help me. Thank you.
Thanks very much. So I have an initial question, if I can. The current power is 2 kilowatts, solid state laser, and do you see a lot of problem with being able to expand that to a higher powered laser in a solid state format with the solid state laser efficiency issues?
So, is this working? No?
Yeah, you just got to get close enough.
So the system we have on the Stryker can take up to a 10 kilowatt laser. So, yeah, that's the system shown. Beyond that, we'll have other...
I guess your mic isn't working, Dave.
You have to lean pretty close. We'll share. So the system on the Stryker, that can take up to a 10 kilowatt laser. And I think there's easily room within the Stryker to do that. Beyond that, we have designs with larger beam directors that can take yet higher power lasers. And we're comfortable up to approximately 50 kilowatts within the Stryker.
And then, I'm sorry, go ahead.
Just what, for those of us that are not as familiar perhaps with some of the details of how a laser effects might occur, what kind of 2 kilowatts, 20 kilowatts, 50 kilowatts, what type of effect would you be able to have with that type of system?
You want to answer?
Okay, yeah, sure. So I think that brochure we're handing out spells out part of that. Great, thanks, Jessica. It doesn't double with, if you double power, it doesn't double range. Don't let your head go there. But I think what's in that brochure is with 10 kilowatts up, we can take down UAVs out to about 3 kilometers, I believe is what we've published. Yeah? Okay. So with 2 kilowatts out to about 1 kilometer.
And I think what we're seeing out on the range also is that it has ground target applicability as well. We've engaged a number of simulated ground control stations that would be controlling UAVs. It could easily be used to disable optics. Vehicles, we can burn holes in metal. So there is very definitely a ground attack capability inherent with this capability. And the higher the power goes, the longer the range you get, and the shorter time you have to be on a target. So we feel that multi-mission capability, that we could probably do the integration at somewhere between 5 and 10 kilowatt levels of power on an existing platform. Beyond that level, we think it would probably take a dedicated platform to provide the cooling and the battery power, the power generation that you would need.
Thank you. Terry Baker from Telephonics. Does the atmospheric absorption dissipate the beam enough so that it doesn't harm friendly aircraft or assets if you miss like you did in the test results?
So yeah, so first off, we didn't miss in the test results. Typically, we don't fire the laser unless we've got solid track on it. The laser weapon integrates with the command and control structure resident at the range. So we have a complete air picture and understand friendlies or others that are in the airspace so that a inadvertent illumination won't happen.
And just to emphasize Dave's point, yeah, the system doesn't miss because you're traveling at the speed of light. If you have a lock on the target, when you engage, it's going to hit the target. It's not quite like a bullet where you're hopeful that the ballistics work out correctly.
And that would be the same for the ground application as well?
Right. Yeah, right.
Right.
You have solid track and positive visual ID of what you're pointing at, and you see it lays while you're doing it.
Thank you.
It's more exciting inside a vehicle than outside because there's no sound and there's no sight. When it fires, and you only know it by watching the effect on the target.
Other questions? One more?
You're an integrator, so yeah, that's a great weapon. But in integrating these high power use things in vehicles, I know your company used to have a technology thrust called power management.
Right.
And it's all about getting ready for whatever all these future uses are and how they're going to stack up, whatever. We tend to look at them in isolation. I'm wondering, is there a wave coming that we're ready for in the vehicle world, or not, for how to manage, store, and deploy this power
Sure, that's
throughout
a
the
good
vehicle?
question. And I don't know if anybody heard that. I couldn't tell because I was right in front. The question was, what are we doing on the vehicle power side and battery side to be ready for this kind of high demand system power management? The vehicle today generates enough usable power for a system of the size that we have on the vehicle out at Fort Sill. As the power levels increase, then it becomes more problematic. But on the vehicle side, family of vehicle side, we have a range of capabilities for power that range from 20 kilowatts to 120 kilowatts off of a Stryker size vehicle. And then we're also experimenting with a lot of different battery storage capabilities because the system fires off a battery power, and the question becomes how big a bank of batteries and how fast do you need them to recharge in order to meet the required mission cycle of the weapon. So I think there's capability coming in the near future. One example is the inline starter generator that we're working with Tardec on that can produce 120 kilowatts of power through the drivetrain. We have other options to produce that much power directly off the motor. So we think we can provide the power. Cooling will be a challenge. That's intensive swap bill to cool the system. So that, in our view, is the bigger challenge, even greater than power.
Yeah, but after you fire, and if you fire multiple times, is there a big problem with how that power gets replenished?
Yes, and it's a question of how big is your battery bank in terms of the number of shots it can provide to the laser before it is drained, and then how quickly those batteries can absorb the power from a power source like an engine and recharge themselves. So I don't know, Dave, if you want to add to that. Okay.
Questions, others? All right. Gentlemen, thank you very much.
Thank you for your time.
Appreciate your